Good evening, everybody, and welcome to tonight's talk. Tonight we have Kit Chapman, who is a science journalist. He has also recently been elected to the IPAC trivia team to talk about the elements for the governing body for chemistry. Tonight he's going to be talking about how to name your element. A couple of little bits of housekeeping. We have got a Q&A session at the end. The way we're doing that is through Slido. So if you have a question, go over to Slido, slide.do/elements. I believe the link will be in the chat. And you can ask a question, or if you want to, you can vote on which questions you think are going to be the best ones to have answered. We are also asking for donations to help us run this. So just a small donation. Again, the link will be in the chat. But thanks. Apart from that, I think it's time to say hello to Kit and let Kit talk about the periodic table.
Thank you very much. Hello, everyone. Thank you for coming to a talk about chemistry. I appreciate this is probably inflated crowds because of the lockdown, but here we go. My name is Kit Chapman, and my area of expertise really are the elements that don't exist on Earth. So I wrote a book called Superheavy last year, which is about how we actually create elements now. But I'm going to talk to you a little bit about how we name them. To give you a little bit of background of what I do, I used to be a science journalist for Chemistry World magazine. And following from that, I've been going around the world doing all kinds of strange and odd science adventures. So top right there, when I'm looking like Peter Griffin from Family Guy, that is me next to a particle accelerator in Germany. That's 109 meters long. It can shoot particles at about 80% the speed of light. Down the bottom, if we go clockwise, that's me at the Himalaya Glacier in Chile. I was there last month, which was astonishing to go to. There I am in the middle of the Amazon jungle with a tribesman there. That's actually off the Rio Negro, which is near Manaus, so about 2,000 miles down the Amazon River. And finally, the current book I'm working on at the moment is technology that goes into Formula One and Formula E cars. And there's an example where I've been working with the Envision Virgin racing team over in Valencia. But you're here to learn about the periodic table and some of the weird, strange facts. And there's a very simple question that got me interested in the periodic table to begin with, and it is this. Can you name an element lemmium? I probably should explain. Towards the end of 2015, 4 new elements were confirmed as discovered by IUPAC. That's chemistry's governing body. And there was a campaign, because Lemmy had died at around the same time, to name an element after him. 144,000 people signed this petition to name an element lemmium because they were heavy metals. Terrible chemistry pun, but there you go. And so I started learning about the rules of why and how we name elements. Can you do this? Can you not do this? And it's a fascinating subject. I'm going to delve into all kinds of different names around the periodic table. But let's begin with the very basics. What is an element? Now, here are 5 people, and they would tell you very different answers if you ask them that question. On the far left, we have Paracelsus. Paracelsus was an alchemist, and he'd tell you that elements are the Greek idea of earth, air, wind, or fire. Paracelsus, very interesting chap. He was an alchemist in the good sense. He was a proto-chemist. One of his most famous things was the dose makes the poison, which is absolutely correct. A little bit bonkers, he wrote a book about how mermaids wanted to marry Christian men so that they could steal their souls and get into heaven. The book became a bestseller. It inspired Hans Christian Andersen, who later inspired the movie The Little Mermaid. So if it wasn't for this alchemist nutjob from Switzerland, you wouldn't have The Little Mermaid. And he was sort of contemporary with Henry VIII. Moving along, this is Antoine Lavoisier and his wife Marianne Lavoisier. Don't be fooled. She is much younger than she looks in that photo. She was 13 when she married him. They were both good scientists in their own right. Antoine Lavoisier, very much the father of modern chemistry. Some elements are credited with his discovery. And his wife is a part of that story because Marianne could do something he couldn't. She could speak English. And she read in a book, an English book, that a guy called Priestley had discovered something called dephlogisticated air. Now, phlogiston theory was very popular in the 18th century. It was the idea that there was this hidden element that was about combustion and fire, and that's why things burned. And Antoine Lavoisier thought dephlogisticated air is a stupid name for an element. Let's just call it oxygen. So he is where we get that from. He got killed during the French Revolution. He was a French aristocrat. Those kind of risks happened. He got killed by annoying the tobacco industry. Very strange life. But his big addition to chemistry was the idea of elements and what they actually meant. He tried to gather up things that he couldn't simplify any further. So, for example, if you take water, you can simplify that into hydrogen and oxygen. If you take iron, you can't simplify that further. It's just iron. And so he decided those were the elements, and he came up with a list. His list wasn't perfect. He thought that calories were an element. He thought that light was an element. But it was a good place to start. And from Lavoisier's list, we started to build up a picture of what the world was consisted of, the basic building blocks. And that's where we get to the next guy. That is Dmitry Mendeleev, a terrible human being. Dmitry Mendeleev, in his later life, fell in love with one of his teenage students. Her parents found out and moved her to Rome. He was in St. Petersburg. He crossed Europe, followed her to Rome, and said that he would commit suicide if she didn't marry him. She came back to Russia. He then bribed a priest so they could marry. Why bribe a priest? Because he was already married. Dmitry Mendeleev was a bigamist. The Tsar of Russia famously said, "Dmitry Mendeleev may have 2 wives, but I only have one Dmitry Mendeleev." Now, his big addition to chemistry was, of course, the periodic table. What he did was he took the list of elements that we knew about and he arranged them by weight, but importantly, he also arranged them by properties. If you group them in certain ways, you can discover that the properties increase or decrease as you go up and down the table. For example, lithium, if you put that in water, it fizzes. If you put sodium water, it bursts into flames. Potassium, it explodes. And so Dmitry Mendeleev created this table and he left gaps. And that was the important thing. He thought that we hadn't quite got it right. And his gaps turned out to be correct. When they were filled by elements that were discovered, everyone worked out the periodic table was a real thing. But even at that point, they didn't know why it was like that. It wasn't until a guy called Moseley, who was killed during the First World War, we worked out that there was something to do with the charge of the nucleus in there. And that reaches us to our final person. This is Darlene Hoffman, one of my favorite chemists of all time. She's still alive. She's 93 years old. Darlene Hoffman would tell you about the nucleus. Because inside the nucleus, we have protons. Protons are positively charged. And as we add another proton, we get a new element. So hydrogen has 1 proton, helium has 2, lithium has 3, and so on, right up to oganesson. That's the heaviest element we know of, and that has 118 protons. And inside, because protons are positively charged, you need some sort of packing filler, and so we have neutrons in the nucleus as well. The reason I bring up Darlene Hoffman is that she was one of the most unlucky people when it comes to element discovery. She was supposed to head up a team at Los Alamos that was analyzing debris from a nuclear bomb. And she wasn't allowed in the lab. HR looked at her and said, there must be some mistake. Women are not chemists. Get out. For 3 months, she wasn't allowed into Los Alamos to head up her team until the FBI was called in, who suddenly went, actually, she's kind of in charge of the whole thing. While she was stuck at home raging against the system, in her words, 2 elements were discovered from the debris of the nuclear blast. So she should have had 2 elements credited to her. As it is, she had none. Now that's what an element is as it progresses through the centuries. Let's talk about names. And who discovers elements is an important thing to come into because the person who discovers an element gets the first dibs on naming it. They don't always get the chance. Sometimes it doesn't happen. Sometimes another person claims the discovery, but they're supposed to get the dibs. It does bring up some questions, though. The guy on the far left there, that's Andreas Marggraf. And in 1746, he was a German chemist. He claimed the discovery of zinc. Here's the problem. If he discovered zinc in the 18th century, why was it being mined in India 1,500 years earlier? Element discovery is very much a Western concept. Other examples, my favorite one probably is platinum. The conquistadors discovered platinum by taking it from Amazonian tribes. So bear in mind that when we talk about discovering elements, we're not always correct. Also, ancient elements, we have no idea who discovered them. Anyone could have discovered copper, gold, silver, but I can tell you pretty much it wasn't going to be a white bloke. Next on the list, looking incredibly dapper, is Humphrey Davy. No one ever talks about how Humphrey Davy was a handsome man, but anyway, I know one of the editors of Nature has a massive crush on Humphrey Davy. He discovered several elements because he was an expert in electrolysis, and he could basically separate things out and discover these elements, things like sodium, things like potassium. One of the elements credited to him is chlorine. The problem is that he announced it to the Royal Society that he'd discovered it. He almost certainly didn't. A guy called Carl William Scheele discovered 6 elements, chlorine and oxygen actually among them, as well as things like barium. He is credited with no discoveries because other people kept nicking his ideas. Pointing to the periodic table there, looking incredibly dapper, is Sir William Ramsay, fantastic chemist, British chemist. And he discovered the noble gases, the gases that don't really react very much, things like neon, argon, xenon, krypton. Now, his discovery really sent shockwaves because they didn't fit into the periodic table system, because no one imagined that there were these elements with complete electron shells, essentially. Which is why they are unreactive. And he named his elements all kinds of. Argon means lazy. He liked to have fun with it. But Mendeleev insisted for ages that the noble gases didn't exist and that William Ramsay must have got it wrong. Ramsay himself, while he was an element discoverer, also messed up someone else's chances. There was a guy called Matasaka Ogawa who was working under him in London. And he came up with, he thought he discovered an element. He brought it over to Ramsay. Ramsay said, go for it. They call it neponium. And it turns out that it wasn't. And that is going to cause problems later on. The final person on the far right is Lise Meitner. Everyone mentions Marie Curie to the point that Marie Curie always looks fed up of being the only chemist ever named on screen. That is, she's a physicist. Lise Meitner was overlooked for the Nobel Prize 42 times. Her lab partner, Otto Hahn, did win the Nobel Prize for the discovery that she helped him do. In fact, pretty much everyone else in that team was recognized. She was ignored. And the discovery was nuclear fission, this idea that you could smash 2 elements together, 2 atoms together, and cause an explosion, breaking them apart and releasing energy. Of course, this is how nuclear power gets started. And this is how we actually begin the age of element creation. Because the reason we discovered this was messing around with an idea that Enrico Fermi had come up with. Enrico Fermi, one of the greatest physicists of the 20th century, and he was taking neutrons, these neutral non-charged particles, and he was firing them into an atom's nucleus. I just realized what that's going to look like on camera. I'm really sorry. And he was trying to fuse them together, and he noticed that he had created something he didn't know. He assumed it was a new element. In fact, he won the Nobel Prize for discovering 2 elements beyond uranium. He didn't. What he'd actually discovered was nuclear fission. So Enrico Fermi, the great irony of his life, was this amazing physicist who should have won multiple Nobel Prizes. He only won for the one thing he didn't do. Moving on, let's have a look at the periodic table, because this is the perfect place. This is the periodic table as it might have looked in 1936. And the periodic table, as you can see, there's quite a few elements in there. Everything's mostly in the right place. A couple of sticklers will notice that 90, 91, 92, and 89 are in the wrong place. That wasn't discovered until a bit later on. We didn't realize there was something called the actinide series. But there's a couple of gaps. And those gaps are the elements that are too unstable to exist for a long time on Earth. Any element we dig up, we find in the ground or elsewhere, I mean, iodine was discovered from seaweed, has to have a half-life, a radioactive half-life, of several million years. Otherwise, it's not going to have been there from when the Earth formed. And the elements that are missing there are the ones that are radioactive and have to be found in other ways. The exceptions are things like radon and radium 88 and 86. Those elements were discovered by Marie Curie. Radium was, and polonium as well. And that was basically done through intense lab work. But most part, those are the elements that exist on Earth. Today, the periodic table looks more like this. This is all 118 elements. And we are now in the area where these elements, particularly the super heavy elements, the ones I've got in a little red box, last for hours, minutes, seconds. Oganesson is, we're looking in thousandths of a second. It's incredibly unstable. And the problem there is, how do you prove that you've discovered an element? Now, we've got definitions for that, fortunately. We say that an element is anything that exists longer than 10 to the minus 14 seconds. That's the time a nucleus takes to attract an electron. But even so, we've got to be able to prove that those elements have existed. And that's really, really hard when they vanish in the blink of an eye. Here's how we make them. We use big machines and we get tiny amounts of them. This is a machine that was used in Berkeley in California. There's actually several Nobel Prize winners on there. I'm going to try and point them out if I can. Laser pointer. So that is a guy called Ernest Lawrence. He was the guy that invented this machine. It's called a cyclotron. It's a type of particle accelerator that works more or less like a reverse whirlpool, using electromagnets to make particles go faster and faster as they spin out. And it's more compact than a long linear particle accelerator, which can go on for about 100 or so meters. We've also got down there, that's Luis Alvarez. He's the guy that came up with the idea that dinosaurs were made extinct by meteor. But before that, he actually won the Nobel Prize. We've got a guy called Edwin McMillan there. He was the guy that actually discovered the first element past uranium, called neptunium. I think that is Phil Abelson who did it with him. There's a couple of other people in there as well. There's Melvin Calvin, who made the Calvin cycle. And I think somewhere a guy called Glenn Seaborg, who we'll come on to because he's one of my chemistry heroes. And these big machines would make tiny, tiny amounts. The photo on the right there, that tiny little dark stain, that is all the plutonium that existed in the world in 1943. And that is next to the head of a needle. It's incredibly difficult to make large quantities. And the reason we managed to make nuclear bombs is we actually upscaled it. Enrico Fermi built a nuclear reactor solely to upscale the manufacture of plutonium so that we could make nuclear weapons with it. As it turned out, fantastic for power. The first one was actually built on a squash court, strictly speaking a rackets court, but a squash court, underneath the bleachers of the sports stadium at the University of Chicago. Not the ideal place to build a nuclear reactor. But today, element discoverers look a bit like this. The big problem with these machines, as I mentioned, is that we have a problem with making large amounts and proving that a discovery has happened. And this came to a head in something called the Transfermium Wars. They lasted 40 years, during which both America and Russia, the USSR, claimed to have discovered elements. So they started calling them by their own names. Element 102 in the US was known as nobelium. 103 Lawrencium, after Ernest Lawrence, the guy who made that particle accelerator. The Russians weren't happy with that. They went with Joliotium, after a guy called Frederick Joliot-Curie. He was married to Marie Curie's daughter, Irene Joliot-Curie. They both won Nobel Prizes as well. And they wanted to call 103 Rutherfordium. The US, not happy with this, decided that 104 was going to be Rutherfordium. And suddenly you had two elements with the same name. Now, this is going to cause absolute chaos. The Russians wanted Kirchatovium for 104. The Americans hated that. I'll come into a little bit about why later on. And so the US started calling their own name. And everything got chaotic. IUPAC, chemistry's governing body, tried to sort this out. In the early 90s, they came up with a list. In 1994, they rearranged the elements as this. You might notice 107 and 108 have names now. They were discovered by a German team. They weren't involved in the Transfermium Wars at all. And yet they kind of got dragged in because, as you can see, the Niels Bohrium becomes Bohrium. Harnium gets dragged into 108. Nobody liked this list. The Americans were particularly unhappy that SEABORGium got kicked off. Glenn Seaborg was still alive at the time, and they wanted to honor his contribution to the periodic table. He was the guy that discovered plutonium and several other elements. I'll come on to that a bit later on. And so there was a whole lot of wrangling until we got the actual list that we eventually have to this day. And so you can see that Rutherfordium has been element 104, element 103, element 106. So we've talked about the element names as they bounced around in the Cold War. Just to give you an example of element discovery today, here are people who have discovered elements since the Cold War, and this is actually 21st century element discoverers. On the far left, we have Kosuke Morita. He's so popular in Japan, they have now created an anime about him, a little manga comic. We've got Dawn Shaughnessy there. True story, Dawn gave me access to her lab because I shared I should probably give some context to this. Dawn is a massive Star Wars fan, and my brother used to work in a comic book shop, and I remembered that I had a piece of Star Wars memorabilia. I had this signed photo poster, from David Prowse, the guy who played Darth Vader. And I said to her, if you let me come and hang around your lab and see what you guys do, I will give you my signed David Prowse movie poster. I forgot that David Prowse had signed it, "My lightsaber is bigger than Hayden Christensen's, yours, David Prowse." So that is now in a US nuclear lab somewhere. Never mind. Next, we have Clarice Phelps. Clarice is one of the discoverers of element 117. First African-American woman to discover an element. Not the first African-American. There was a guy called James Harris in the 1960s and 1970s who worked with the Berkeley team. And finally, that is Yuri Oganessian. Oganessian is the only living person with an element named after him. Really nice guy. He's 87 years old now. Fantastic guy. So here's a couple of people who didn't discover elements. I know this is a Skeptics talk. Up the top there, that's a guy called Viktor Ninov. He actually was an element discoverer genuinely in Germany. He then moved over to Berkeley at the end of the 90s and claimed to have discovered element 118. The only problem was he hadn't. It later emerged that the data had been falsified and that someone, presumably Ninov, had tried to fake the discovery of an element. He was removed from the community and all kinds of questions were raised about his previous work, things like that. The guy down the bottom is Bob Lazar, who's probably very familiar to a lot of skeptics for his UFO theories. He claimed that element 115 had been discovered, given to us by the aliens in Area 51, just outside Las Vegas, and that it's used to power alien spacecraft. If that's true, Moscovium, which is element 115, is really doing a job because it is not the best fuel for spacecraft at all. But I thought I'd throw them in there just as you guys do like your skepticism stuff. So let's get on to the names because that's really why we're here. How do you actually name an element? Well, the 2015 rules came in, and this is all about Lemmy, remember? No offensive words. You cannot name an element something rude. They must all end, by the way, in IUM, unless they are a halogen in which they end INE, or a noble gas in which they end ON. No former element names. That's quite a biggie. As I mentioned, you can't have an element name that has already been there. It just creates confusion, and we want to try and eliminate that as much as possible. You can name an element, however, after a mineral if you want to. You can name it after a property of the element, something that it has and does. You can name an element after a place, a scientist, or a mythical creature. Now that sounds like it's quite sort of a narrow scope. It's actually the complete opposite. Every single element on the periodic table, this was designed by a guy called Andy Brunning at Compound Interest, fantastic chemistry educator and science communicator. And here on the, you can see the names and origins of every single element on the periodic table, and they are all named after minerals, mythology, a person, a place, including an astronomical body or a property of that element. And astronomical body is quite important because Neptunium and Plutonium and Uranium are all named after the planets. They are not named after the gods. Uranium existed already. It was named at roughly the same time as the discovery of the planet Uranus in the 18th century. And when Neptunium and Plutonium were discovered just at the start of the Second World War in America, they decided to follow suit. Originally, they were using code words for it, and they were calling plutonium copper. Until that was fine, until they actually needed some copper for some work, in which point copper became honest to God copper, and they thought, okay, we just need to name the elements. So they just tagged on from the planets. Usually a symbol will be the first letter or first two letters of an element, unless that's taken by something else. Plutonium is an interesting exception to that rule. It should be PL. There is no PL on the periodic table. But Glenn SEABORG remembered how stinky the attic was. He made plutonium for the first time and decided to call it PU, which goes for humor in the 1940s. Now, so I'm getting some crackling on the mic. I don't know what that is, but I'm going to continue on regardless. Now, the no offensive words rule has come up several times, more than you'd think. So the German team I mentioned earlier, they discovered 6 elements in the 1980s and 1990s. And they're based at a place called Wixhausen, just outside Darmstadt in Germany. The problem is that Wixhausen, well, there's no way to get around it. It means place I go to masturbate in Germany. So in German, it's incredibly rude. They suddenly realized they can't have an element called Wixhausium because everyone's going to think it's a wanker's element. Also coming up, these are real names that were suggested: Bomium and Bastadium. They were suggested by the Americans shortly after they created elements Americium and Curium, because they had been such an arse to make with the Bomium, Bastardium because it was a derivative of another element. Can't have that. Littorium, that was actually suggested by Benito Mussolini. As I mentioned, Enrico Fermi in the 1930s thought he'd discovered an element. It turned out he was wrong, but Benito Mussolini suggested calling it Littorium after the lictors of ancient Rome. And the lictors were the people that carried a bundle of sticks known as the fasces, and that's where we get the word fascism from. So we almost had a fascist element. Of course, anything like that today would be banned. And finally, Kurchatovium. I mentioned this earlier, a Russian proposal during the Cold War. Igor Kurchatov, was the mentor of the head of the Russian team. However, he was also the father of the Russian atomic bomb project. The Americans objected to that. They found it politicizing and incredibly offensive. Ironically, the Americans ignored the fact that Glenn Seaborg invented plutonium and was heavily involved in the American atomic bomb. But, there you go. Double standards for you. I also mentioned no former element names. This is a photo of Japan. And Nipponium, as I mentioned, was discovered by a guy called Agawa in the early 20th century. William Ramsay said, "Go ahead, name the element Nipponium," and for about 30 years, everyone called it that. It later emerged that what he thought was his discovery, element 43, was completely wrong. That would become technetium. It was discovered in Sicily by one of Enrico Fermi's pupils, Emilio Segre, in 1937. And he got it wrong. And that meant that no element almost could be named after Japan, because Nippon is the Japanese word for Japan. Fortunately, there is another word for Japan, which is Nihon. And so that is why the element 113 is Nihonium rather than Nipponium. Cassiopium was a German name for the element lutetium. And this caused chaos for about 50 years because the Germans insisted on calling the element Cassiopium, while everyone else in the world called it lutetium. Eventually, they sort of conceded the point. So no element will ever be called that. Hahnium, as I mentioned, Otto Hahn loses out. And finally, Stickstoff, which is my favorite rejected name. That's what the Germans used to call nitrogen. But we will never, sadly, have an element called Stickstoff, not least because it doesn't end IUM. Here are the minerals. I mentioned that it could be from a mineral. That's a picture of Cornwall, predominantly because Humphrey Davy discovered a lot of elements with mineral names. Sodium, for example, from soda. Potassium from potash. Boron is also from a mineral. For ages, that was only ever found in Tibet. Boron is one of the weirdest elements on the periodic table. The more you know about boron, the stranger and weirder it gets. But that comes from borax. And samarium, this is where it gets very confusing, because I mentioned it could be named after people as well. Samarium is named after samarite, the mineral that it came from. And samarite was named after a Russian mining official called Semersky Bovets, who someone was sucking up to him one day and decided to name the mineral after him. So all kinds of things can combine on the periodic table. Properties of an element, I mentioned that. That's chlorine being tested by the US military. Chlorine is a great example of an element named after its properties. It means yellowy green, which obviously is the color of the gas. Argon, we've discussed before, that means lazy. Technetium, it means artificial. It was the first man-made created element, so human-made element. Neodymium is a bit of an odd one. It's part of two elements that are basically almost identical. They're essentially twins. There's praseodymium and neodymium. Neodymium means young twin or new twin. And for ages, people thought these two elements were the same because praseodymium and neodymium pretty much very, very similar. They sit on the kind of the weird naughty step of the periodic table that exists down the bottom in what's called the lanthanides. Places is an interesting one. This picture is a place in Sweden. It's about as big as your living room. It's tiny. That little sort of that trail leads off to a tiny little area. That's a little mine, and it's in a town called Ytterby. A town. It's got about a population of 300. It's really, really small. To get there, you need to fly to Stockholm. You then have to get a tube to the end of the line. Then you get a half-hour bus ride onto an island called Rosario. Then you walk for half an hour. You get to this tiny little village in the middle of nowhere. And there, in the late 1800s, I think, a young Swedish artillery officer was looking to put a place to put his cannons. And he was kind of interested in geology. He found this black rock in a mine they had in Ytterby, and took it to a friend of his, who sent it off to another friend called Gadelin. Gadelin looked at it and discovered that this rock was like nothing they had seen before. And in fact, this was now the richest source of elements in the world. The village of Ytterby is responsible for at least 8 elements, possibly 10, depending on how you count them, all coming from this black rock. So Ytterby has several elements named after it. You've got ytterbium, yttrium, terbium, and erbium, gadolinium, thulium, scandium, holmium, Scandinavia. Thule is an old word for Scandinavia. Holmium after Stockholm. Dysprosium, that means hard to get at. Lutetium, which is that's actually named after Paris. It's the Roman name for Paris. That's where they actually isolated it finally. So all kinds of elements have sprung out of this tiny little village. Copper, a lot of people don't realize that's named after a place. Copper is the Roman word for Cyprus, which is where they took it from. Strontium is the first element named after a place in the UK. It's the only place that has an element named after it in the UK. It's the village of Strontian in Scotland. It is tiny. It's almost as big as Ytterby, actually. But there you go. And helium is an interesting one. It's the first element we discovered off-world. We discovered helium during an eclipse of the sun. We were looking at spectra in India, and we noticed that something new was coming out of there. So helium is named after Helios and the sun. Scientists is a really interesting topic. This is I love this photo of Glenn Seaborg. He looks like something out of a noir magazine. And good examples, gadolinium. We just mentioned Gadolin and his work with the things that came out of Ytterby. Meitnerium, after Lise Meitner. Lawrencium, after the guy who made the cyclotron. And Seaborgium, after Glenn Seaborg, the guy who discovered plutonium in that tiny, smelly attic. And Glenn Seaborg, he was still alive when the element was named after him in 1997. He actually died in 1998. And so you could have written to Glenn Seaborg. This is a strange picture of him. He actually announced the discovery of 2 elements, americium and curium, while he was on a children's game show on the 11th of November 1945. He was on his way to a chemistry conference, asked to come onto this game show. One of the kids said, Dr. Seaborg, have any elements been discovered recently? He couldn't hold it in any longer. He went, actually, we've just discovered another 2. It is the only time elements have been announced on a children's TV show, radio show, and the only time elements have been sponsored by Alka-Seltzer. But when he died, you could have written to Glenn Seaborg using elements that he discovered. You could have written Glenn Seaborg, Lawrencium Berkeley. He was at Lawrence Berkeley National Laboratory. Seaborgium, Lawrencium Berkeleyum, Berkeleyum, Californium, americium. And some people actually did try it, and the letters did arrive to him. I've actually tried similar with Yuri Oganessian, who's, as I say, still with us. I wrote to Oganessian Flerovium. He was at the Flerov Labs. Dubnium, that's the town he's based in. And I couldn't work out how to do Russia, so I just put the symbol for ruthenium, which is RU. It didn't arrive to him, sadly. So it looks like the Russian Postal Service doesn't have a sense of humor. Now, finally, I mentioned mythology. You can name elements after mythological creatures. This is obviously not a mythological creature unless you think that Michael Fassbender is an Adonis, I guess. It's from the movie Prometheus. Prometheum was named after the mythological man who gave the god Titan, I think, wasn't he? Something or other, who gave man fire. Element 61. Prometheum is the only element we know that was directly fueled by Kentucky Fried Chicken. So it was discovered at a place called Oak Ridge, which was a secret military base in Tennessee during the Second World War. Around 70,000 people worked there, but no one went in, no one went out. And Harlan Sanders, who would later become Colonel Sanders, was the assistant cafeteria manager there in charge of feeding the scientists. So we know that Prometheum was discovered with the help of Colonel Sanders. Other examples, you could have vanadium. Vanadium is an interesting one. It was discovered by a guy called Del Rio, Andres Del Rio, in Mexico. and he was persuaded by his colleagues at the time that he hadn't really discovered an element. Just leave it alone, just forget about it. It later emerged that he had discovered an element, but the Swedish get everywhere in these stories. There was a Swedish chemist who decided that he would name the element that Del Rio couldn't. Del Rio died following that, and he decided to name it after the Norse goddess of love, who is Freya. Now, he didn't want another Fe on the table, that means iron, so he was looking for something else. He thought there's no V's on the periodic table, so I'll use the alternative name for Freya, which is Vandis. And so we have vanadium, a Mexican element that is named after a Norse sex goddess. There you go. The only Avenger on the periodic table with an element named after them is Thor. That's thorium. Obviously, we do have Captain America for americium and Iron Man, I guess. But I think they had the elements before them. And finally, of course, we have cobalt, and this is my personal favorite. Cobalt is named after a yapping German mine spirit that was said to go into iron mines and ruin the quality of the iron. The yapping spirit was called the kobold. Now, the kobold, for any D&D nerd, is basically a key part of the monster manual. It is a small dog-like creature. And this is why I think a game called Baldur's Gate that came out in the 1990s is the greatest computer game of all time. Because the plot of Baldur's Gate is that the kobolds have gone into an iron mine and are poisoning the iron. Sorry if I've spoiled the first half of Baldur's Gate for anyone. But cobalt, the only element that appears in the D&D monster manual. So, let's go back to the question that started it all. Can you name an element Lemmium? The answer is no. Sadly, I would say he's a rock god, but he's very clearly not a mythological creature. He's not a place. He is not a property of an element or a mineral. And he is not a scientist. But fortunately, there are some scientists / rock gods that are available. So, no, you can't name one after Lemmy, but you could name one after astrophysicist Brian May. I hope that explains how we name elements, why we name elements, and has given you a little bit of a whistle-stop tour of the periodic table. Given our technical troubles, I've sped up quite a bit and skipped a few things. But if you have any questions, I'm more than happy to answer them in the Q&A. I'm happy to talk about things like how we actually make elements and some of the future elements that we could have as well, because we're currently looking for elements 119 and 120. If you want to know a bit more about that kind of stuff, my book is called Superheavy. My name has been Kit Chapman, and apologies for the technical problems we've had, but I hope you have enjoyed the talk.
So again, welcome back, Kit, and we'll go into our first question for you.
Okay,
so,
can you see me now, by the way?
We can see you.
Fantastic. Hello, everyone.
Yeah, we can see you and hear you, which is always good. So from Johnny L, are any of these super short-lived elements actually particularly useful?
That's a really good question. The answer is yes. So the elements initially beyond uranium, what we call the actinide elements, the first ones that we discovered, obviously plutonium, we use that for power, we use that for nuclear weapons as well. Americium you'll have in your home. That's now used in smoke detectors. It's one of the main reasons of why a smoke detector works. It releases something called alpha radiation, which can be very easily blocked by things like a piece of paper or some smoke, and we use that for safety. So it's probably saved more lives than nuclear power could possibly have cost. Also, curium, that's one heavier, that's element 96. We use that in some cancer treatments. But the really heavy ones, the super heavy elements, currently we don't have a use for them much outside the lab. They are far too short-lived. There is a theory that's called the island of stability, and that says that for certain numbers of protons and neutrons, what's called magic numbers, you can create a more stable nucleus that could last potentially hundreds, maybe even thousands of years. If that's the case, we could get fluorovium, element 114, to last a long time. Potentially, we might be able to find it on Earth. In the 1970s, there was huge amounts of searches. The one thing we can do is understand more about our universe and how our universe is formed. We know these elements exist in neutron star collisions, for example, and so we can actually map supernovae by studying them and understanding their properties. Oganesson is particularly weird because it should be a noble gas. It's in that noble gas group. It's got a complete electron shells. The problem is that we think the electron shells are more like an electron soup. And so it's highly reactive, and it's probably a solid at room temperature, not a gas. So the more we understand about these super heavy elements, the more we can understand about how the world actually is put together.
Fantastic. Right. Next question. Is there a theoretical upper limit for an element size?
So there are several different ways of describing a theoretical limit for element size, both in terms of the nucleus itself and in terms of the number of protons we could have. The upper limit supposedly for protons is around 172, 173. If that's the case, we're still missing 1/3 of our periodic table, and we can continue making elements up to that. The problem is, in terms of how we think theoretically these things will go, it starts getting really, really weird. At about 130 or 140, we're going to see elements that potentially could have nucleuses with holes in them, like donuts, for example, as they try and sort of twist and contort to exist. We could have an area where they don't attract electrons at all; they're just bare cations. In which case, do we call them an element? Big questions we don't know the answer to. 172, 173, that's when it hits what we call the Dirac sea, and that's a sea of instability. We don't think we can make elements beyond that. Another way we can talk about limits are what we call isotopes. So isotope is a different version of an element. So, for example, when we have a little number about it, we're talking about carbon-14, for example, we're talking about an isotope. And there is a limit in terms of the number of protons you can have, obviously, because remove the protons, you don't have the elements. And we also have neutrons, and what we call those are the drip lines. And again, we think that we know roughly where those limits are. We have around about, I think, 3,000 different isotopes at the moment, different versions of elements, and we reckon we can double those in the next 5 years. There's a facility called FRIB that's being put together at Michigan State University, and that is the only time I'm going to point to my tits on a live stream. And Michigan State University is doing a lot of research in trying to expand the number of isotopes we know about. There's also work being done in a place called Riken in Japan.
Fantastic. For another one from Anonymous, what is the obsession with ending element names in ium? We have iron, not ion. I'm not even going to try and work out how to say that. Copper, not copperium. Lemmy should just be Lemmy.
The reason is actually form. So all of the ones that don't end in that traditional way, that IUM, are the sort of the ancient elements, if you like. Things like antimony, which the Egyptians used for eye painting. We use it for sort of coal styles. Copper, for example, iron, lead, although that was pluvium in Latin. And the IUM is essentially a Latin translation. It comes back to when scientists predominantly preferred that form. And so the reason we have IUM is just to try and keep all the groups neat. The INE is because all the other halogens do end in that. We've got fluorine, chlorine, bromine, things like that. And in terms of ON and the noble gases, the only one that doesn't end in, and again, it's questionable whether or not you put it there at all, is helium. So it's just to basically fit in the form of how we've got the periodic table set up.
Dave the drummer would like to know, when are we going to get to the island of stability, do you think?
The island of stability, this is what I just mentioned. The big problem with hitting the island of stability, which we think is around flerovium, there's actually several potential islands, is that we don't have enough neutrons. So at the moment where we're creating flerovium, we take calcium, we take a type of isotope of calcium called calcium-48, which has 8 extra neutrons, and we smash it into our radioactive element, and we just sort of merge them together. And that causes an awful lot of energy. So to try and release that energy, we kick out neutrons. And that's why those 8 extra neutrons are really useful for the calcium. The problem is that as we lose neutrons, we get to the more unstable versions, and we get away from the island of stability. We think the center of it is on flerovium 298. Best. So until we can work out a new way of getting more neutrons into the elements we're making, we're very unlikely to hit that island of stability. I've heard optimistic ideas of next 10 to 15 years, potentially we could find a way forward. I think we're more likely to find element 119 and 120 next. Element 120 is potentially on a small island of stability, which means it could last a bit longer than theoretically it would otherwise. If that's the case, that's probably the one we're going to aim for.
Fantastic. If rude words aren't allowed, how did arsenic get away with it?
Oh, very good. Arsenic is from a from a completely different etymology to your bum. Is basically it. And obviously, as I mentioned, once things have entered into common use, that they more or less stay there. There's a couple of sort of strange jokes on the periodic table. There are three elements that basically mean smelly. If you count plutonium with its Pu, we've also got osmium and bromine means smelly as well. But that's about as close as you get. There's a few other strange jokes in there. Gallium, which is named after France, after Gaul, is potentially a joke. The discoverer of it, his nickname was Lecoq. And obviously you can have rooster for gallium. So a couple of cheeky jokes do end up on the periodic table, but nothing rude.
What's your favourite naming story?
My favourite naming story? I do like the... that's a good question. I mean, some of the stories of how things got named. Mendelevium springs to mind. Mendelevium, as I mentioned, Dmitry Mendeleev, terrible human being. But it was discovered by the Americans in the 50s. And a guy called Al Giorso, he was the most successful element discoverer of all time. He discovered it. His problem was he had a particle accelerator down at the bottom of the hill, and he had his chemistry lab at the top of the hill. And he needed to get his highly radioactive element that's constantly breaking apart up there as fast as possible. And so he made a supercharged Volkswagen Beetle. This was about 4 years before Herbie came out. And he would get the thing out of the particle accelerator. He would throw it in acid, hold a vial of acid, rush to the Volkswagen Beetle, leap in, drive up the hill at full tilt, full speed. Or he almost run over several security guards who had to jump out of the way, sprint to the chemistry lab, and then isolate anything that they've made there. Al Giorso, once it was all done, it was set up in the chemistry lab. There was not much to do apart from wait until you've got a radioactive ping. Because as I mentioned, these elements are incredibly unstable. The way you detect them is you actually measure radioactivity rather than look for them. And so he'd set it up next to various measures and things like that. And he'd go off and he would hook up his meters to the local fire alarm. And so if the fire alarm went off, he knew that he had an element discovery. And sure enough, that night, three times the fire alarm went off. Ring, ring, ring. He knew he discovered an element. And it would become Mendelevium. Unfortunately, he forgot to unhook the fire alarm after the experiment. There was one final ping. It happened at about 11 o'clock in the morning. The entirety of Berkeley Lab was evacuated because of this potential sort of nuclear problem. Turns out it was just a false alarm. And he wanted to extend an olive branch to the USSR team, who was obviously the great rivals for them in the 50s. And he decided to name it after a Russian chemist, Mendeleev, and called it Mendelevium. And this story was told to Glenn SEABORG. And Glenn SEABORG went over and told his friend, a little-known guy called Richard Nixon, who was the vice president of the United States at the time. And Nixon flew over to Russia, had what's called the kitchen table debates with Khrushchev. And obviously, he told Khrushchev the story about why Mendelevium is called Mendelevium and what these guys in California got up to with their Volkswagen Beetle. Because Khrushchev arranged for someone to send Glenn SEABORG a signed copy of the periodic table, the book where the periodic table was first announced by Dmitry Mendeleev. So this story is part of the Cold War talks that happened. And it's just a weird way that science connects with politics.
Awesome. Right, another anonymous one. Why are there fewer elements towards the top of the table?
In terms of actually how the table is structured. It's basically how electron shells are filled. Your first electron shell, you got 2 electrons, and you move up. And then as you get lower and lower, we get more and more of them, and we get what's called the transition metals, which are those big sort of bits at the moment that move across this center of the periodic table. I've described that terribly, and chemists are probably going apoplectic in the chat as I just did that. But it's all to do with how electrons are arranged and the electron configurations.
So Dave the drummer's got another question. Why do we group the actinides, etc., and not just have them all in mass order?
That's a really good question. Before the 1940s, as I mentioned, things like uranium were in the table proper. The thing is that the lanthanides and the actinides behave very, very oddly. Normally, you would expect trends to go down the periodic table. So I mentioned lithium, sodium, and potassium. With the lanthanides and the actinides, the trends actually go along across the periodic table. They're very, very similar elements. They are all slightly different, but for the bulk of it, they are very similar. And because they behave so similarly, it's easier just to take them out and put them in a separate group and put them on that sort of naughty step down the bottom. You can fully extend the periodic table and slot them in there. But the big question is which of the elements go into what we call group 3 of the periodic table. And there is huge debate. So currently we have lanthanum and actinium as the group 3 elements on most periodic tables. There is a lot of argument that says that it should be lawrencium. In fact, IUPAC, the governing body of chemistry, actually set up a group to discuss which of these should be the correct one. And if you have a look at a couple of periodic tables that came out last year, I think there was one at St Catherine's College in Cambridge, and they actually put lutetium and lawrencium in group 3 just to sort of stamp where they thought was right. So these kind of debates do rage in chemistry. And the periodic table isn't this fixed thing. It isn't this set thing. It will change. It can move around. If something works better, we do change it. A great example would be when we added the noble gases in. So don't think of the periodic table as this fixed thing. And don't think of the actinides and lanthanides as separate from it in some way. It's just we do that for ease.
Fantastic. Who has the record for naming the most elements?
For naming the most. So the record for discovering elements is a guy called Al Giorso. Al Giorso is a fascinating character. He worked under Glenn Seaborg. He never got anything more than a bachelor's degree in electrical engineering. His view was, why do I need a PhD? I have discovered elements, which is a pretty fair argument. He was the son of a bootlegger. He was a tinkerer when he was a teenager. He set the world record for ham radio transmission, but couldn't claim it because he'd done it illegally. Fascinating character. He ended up getting roped into the discovery of elements by Seaborg. He was applying to go into the Navy, and his wife said, well, why don't you send my friend Helen's husband for a recommendation? And Helen Seaborg looked up they went over to Glenn and said, this is the guy you need to bring in to discover elements. And he also just turned out to be a genius at it. So he's the record holder, 12 elements. After him, you have various different people you could claim as record holders, depending on how you want to categorize it. Humphrey Davy, certainly for natural elements, would be the record holder. The most successful woman of all time is joint between Nancy Stoyer and Dawn Shaughnessy. They've discovered 5 elements, and Dawn Shaughnessy is still working at Lawrence Livermore Laboratory in Livermore, just outside San Francisco, in discovering elements.
Fantastic. So the next one, bit out of my wheelhouse because I haven't read or seen Discworld, but can Discworld's colour octarine be used as an element name, perhaps after a property?
If it was a halogen, you could end INE. I assume that's how octarine is spelled. I've got to admit, I'm a terrible Terry Pratchett kind of fan. I've not read many of the Discworlds at all. I suppose that it would be a stretch. I think you'd have to try and persuade people that you could do it. The problem is that while the element discoverers do have the first dibs, they can have the powers taken away from them. So while they put together an element suggestion, it is only a suggestion. If not all of the element discoverers agree on this name, after 6 months, I think it is, IUPAC remove the right for them to discover it, to name the element, and name it themselves. And if they don't like the name for some reason or other, IUPAC has the right to say that we're going to name the element. They sort of take it from the discoverer. I suspect that might happen if you try to name an element octarine.
Sean Ellis would like to know something I'm sure a lot of us would like to know. Where did the I go from the American aluminium?
Good question. Actually, the official spelling is either. So anyone who tells you that aluminium is spelled incorrectly is wrong. Unless, obviously, if you try and spell it in some sort of ludicrous way, they're probably right. But the official spellings are vary. There is a lot of that kind of thing that does happen on the periodic table, unfortunately. Accommodations are made. A great example is the pronunciation of berkelium. So the Americans call it berkelium. Everyone else calls it berkelium because it's got an E in it, and the Americans just ignore that. So there you go.
Gray would like to know, are there any rules for naming isotopes like deuterium, or could someone get away with naming a novel isotope lemium? How about allotropes like graphene, etc.?
There aren't any rules for isotopes that I'm aware of. Generally, Very few isotopes are named. We're only looking at things like deuterium, as you mentioned, which is heavy hydrogen, and tritium, which is heavy, even heavier hydrogen, if you like. But very few isotopes do have that kind of privilege. Mostly, we just use the symbol and then the number. In terms of allotropes, I don't know that there are any rules. I mean, we've seen obviously all kinds of strange. Buckminster fullerene would be the great example, C60, which is commonly known as a buckyball, and it was named after an architect. So I don't think there are rules for that.
Anonymous would like to know, has there ever been an alternative periodic table with elements grouped differently?
Yes, there have been several. So I mentioned that Mendeleev is the one that we sort of go for the periodic table. He wasn't the only person who came up with various versions. There was a German chap called Mayer who came up with ideas. We've seen all kinds of interesting different versions. You can do it in spirals. St. Catherine's College, as I mentioned, they commissioned what I think is the world's most expensive periodic table because they have that kind of money in Cambridge. And they got this wonderful periodic table that was a spiral. And the spirals lined up the groups. It was made out of silver. I think the platinum one was made out of platinum. The carbon symbol had a little diamond in it. Gold was actually made out of gold. I mean, this was it's an astonishing piece of artwork, but it must have cost them a fortune. So there's all kinds of different ways that you can arrange the periodic table. There's sort of wonderful sort of seashell kind of shapes and things like that. The Chemistry World did an article on it about 2 years ago if you want to know more about this. But there are all kinds of different ways you could arrange the periodic table. We just use this one because it works for us.
We asked you if you had a favourite element naming story. Do you have a favourite element?
So I always go with this really simple answer. Hands up if you know anyone who has an element named after them. So my favourite element has to be Oganesson because I know Yuri Oganessian. He's a really nice guy, wonderful sense of humour, very funny, and so that's my answer.
This one I think could be an enormous answer, so we'll try and keep it short. But how can we improve the way we teach chemistry at GCSE level?
Oh, goodness me. Make it interesting. I'm sorry, that's really harsh for there are some fantastic chemistry teachers out there. I didn't have a great chemistry teacher when I was at school. I think in terms of sort of what we do for most sciences is that we try and emphasize practical skills and knowledge. And then when it comes to the exams, we just sort of bundle everything together. I would love to tell more stories and explain the context of things. We're seeing that more and more. We're seeing why these things are important. But I think understanding the stories and having that visual hook and that mental hook as to why these things are important in context is really, really useful. I'd love to see that just continuing. And as I say, I'm not too familiar with the current state of the chemistry curriculum. Certainly in my day, we didn't do that. I think we're doing that more and more. But I think that's incredibly valuable. And as I said, there are these crazy, wacky stories out there that talking about Ytterby, for example, this tiny village in Sweden. It's one of those weird facts that once you know it, it doesn't leave your mind. And I'd like to think that would help give hooks for students when they're studying and being able to understand the context of what they're learning.
Are the naming rules for elements the same or similar to the rules for naming new species, planets, etc.?
I don't know too much about the rules outside of chemistry. I think that it very much depends on the different scientific bodies. In terms of naming the animals, certainly you've got a much broader palette. You can name an animal after pretty much anything. There's so many of them going around at the moment. I mean, we're discovering a new species of frog, I think, in Suriname was discovered only about 2 months ago. And there was like 4 different species. So there are countless species, and so there's a much more wider flexibility there. I think in terms of planets, generally it's named after the discoverer. The discoverer gets the naming rights. So I think that follows very similarly to chemistry. But bear in mind, I'm not an astronomer. I don't work for NASA or anything like that. I am literally taking that off what I remember from Deep Impact and Armageddon, which could be completely incorrect.
Okay, and I think we'll go for the last question here. So if heavy elements are detected through their radioactive decay, how would we know if we produced an isotope in the island of stability?
Great question. There's other ways you can do it. One of the simplest ways is mass measurements. So if you set up essentially a speed camera, when something strikes the atom, things ping off. If you think about Newton's laws of motion, we can track the speed that's shot through our little camera, and we can work out the mass of that. And once we know what the mass is, then we can work out what it probably was. If it ties in with what we would consider to be a new atom, then that's considered a discovery as well. They actually changed the rules for element discovery, and they only came into force, I think, last year. But that was one of the things the German team really wanted to do. Certainly, there's other ways you can do it. Where it appears in the machine, for example, is another good measure of how something was created. So it's not just the radioactivity, although the radioactivity is considered the gold standard. The US pioneered that technique. The Russians actually used something a bit different in the Cold War. They like to measure what's called spontaneous fission, something just breaking apart. Spontaneous human combustion, essentially only in atom form. And that's how they declared the discovery of an element. But the Americans didn't think that was good enough, and so wanted that removed as a standard. But yeah, there are other ways we can measure element discovery, and the obvious one is essentially setting up a basic speed camera.
Right. Well, thank you so much for that, Kit. That was fantastic. The only thing I think we've got left to do is we did do a poll whilst we were doing this Q&A on people's favorite elements. I'm going to go through them in reverse order, and I'll probably do 6 or 7 of them just to see your thoughts on these names. Now, some of them are rather skeptic areas. They might not be particularly anything that you would understand because some of them are very, very niche. So we'll start off with Ginium, got 5% of the vote.
I'm not. I mean, why limit it to gin? I mean, why? Do you mean the spirit, right?
I'm assuming so. Alice is saying yes, so yes, it is the spirit.
Okay. Well, it depends. If you discovered it at 5 o'clock, that's gin o'clock. So fair enough.
We've got again. Well, it's now gone to 4% actually, but 4% as well as Elementium.
A bit too basic, isn't it? Come on.
The next one is very niche. It's a Martium, after Michael Marshall, one of the organisers here. So,
okay. Is he a scientist?
No.
Then no.
No. We then have Randium, which I assume is after the amazing Randy, who is a hero, a magician in the USA, who is also a founder of Skeptics.
I'm very familiar with James Randi, the amazing Randy, and unfortunately he is not a scientist, but I have much love for James Randi and everything that he's been doing.
We got Covidium.
Come on.
Oh, what? Strike a happy medium.
I mean, if that is the property of that element, then I suppose you could have it. But that's almost as bad as Elementium McElement face or something like that.
I'm not suggesting them. I'm not voting for them either. I'm just reading them out off the screen. We have Bollocks to Brexitium.
Classy. Can't have it. Rude word. But and also political. And again, they try and avoid political stuff.
We have in second. In fact, joint first place. 19% for each of these. Spanish Inquisition. I'm not even going to try and say it.
Spanish Inquisitionium.
Yeah, that's the one.
Is that because nobody expects it? Is it the element of surprise? Fear and surprise.
I'm guessing so. Yes, I'm getting a big fan, Alice.
Fantastic. Tedious Monty Python jokes. I mean, if you're going to do Monty Python jokes, there are better ones available, I think. But okay, fair enough.
And voted joint first, which personal favourite, Skeptium.
Oh, there you go. Well, like I say, I mean, it's. Would you have it for a property of the element? Because it's, you could say you're skeptical about it. You've got things like dysprosium, hard to get at. I think it would be a stretch. And again, it's probably one of those things that's going to cause a lot of problems. Just on the basis of sort of politicization of science. People don't like that kind of thing, which is a pity. But there we go.
So that is all of our element names. So once again, I'd like to say thank you so much, Kit Chapman. We also, he has his book available. There is a link in the chat. I'm sure it's available at all good bookshops. That is
that you can get to.
That you can get to. that is How to Name Your Element. Is that the name of the
No,
book?
it's called Superheavy. And
so yes, please buy Kit's book. On top of that, we are still collecting on PayPal to fund what we're doing here. And also Kit is on Twitter personally a fantastic name. I mean, I don't know how you get better at this. He's at Chemistry Kit. So well done on getting that name. That is a fantastic name for you. And once again, thank you so much for coming and talking to us. Thank you for a great Q&A. And hopefully to the rest of you, I will see you next week for the talk that we've got then.
thanks,
Thank you very much. Thank you. Bye.